Okay, so we're going to be looking at ideal gas laws example problem set number 2. As stated before, I would like for you to copy these example problems down in your notes first, so we don't have to spend as much time writing them out on the videos. So, PV equals nRT. We used it in the last video. Your pressure is always in atmospheres. Your volume is always in liters. Your N is the number of moles. R is 0.0821. Your T is always in Kelvin. Okay, first example problem. If I have an unknown quantity of nitrogen dioxide gas at a pressure of 0.5 atms, a volume of 25 liters, and a temperature of 300 K, how many grams of gas do I have? Okay, so we're going to use PV equals nRT. Now, what we're going to be doing is we're going to find the number of moles and we're going to use our molecular weight to convert it to grams. Okay, so your pressure is 0.5, your volume is 25, we're looking for N, your R is 0.0821, and your temperature is 300 K. Okay, so we're going to multiply this side and then we're going to divide by these two numbers over here. So 0.5 times 25, and we're going to divide it by 0.0821, hit enter, and then I'm going to divide by 300. So I get N is equal to 0.51 moles of NO2. Okay, now as we stated earlier, to go from moles to grams, you have to go through the molecular weight. Okay, so 1 mole of NO2, nitrogen weighs 14 and oxygen weighs 16. So your molecular weight should be 14 plus 32, comes out to be 46. Okay, so our final answer is 46 times 0.51, and you get 23.46 grams of NO2 gas. Okay, next example problem. It says if I have 21 moles of gas held at a pressure of 230,000 kPa, a temperature of 900 Kelvin, what is the volume of the gas? Okay, so we're going to use PV is equal to nRT. Now, your pressure is in kPa, so we need to convert that, get that to ATMs. So we said that there was 101.3 kPa to 1 atmosphere from our first lesson from this unit. Okay, so that's your pressure in atmospheres, 2270.48. Okay, so we're going to plug that in, 2270.48. Your volume is what we're looking for. Number of moles is 21. Your R is 0.0821. Your T is 900 K. So what we're going to do is we're going to multiply these numbers together and we're going to divide by that one. So 21 times 0.0821 times 900 and divided by 2270.48, and you get 0.683. And we're going to be in liters. Okay. Next example problem. If I have 1.9 moles of gas held at a pressure of 5 atmospheres and in a container with 50,000 milliliters, what is the temperature of the gas? Okay, so we're in moles, ATMs, we're gonna have to convert this unit. So to go from milliliters to liters, you're gonna move the decimal place 1, 2, 3 places to the left. That goes back to King Henry died by drinking chocolate milk from our first unit of study for the year. Okay, so you have 50 liters. Okay, now we're going to use our formula. PV is equal to nRT. Your pressure is 5 atmospheres. Your volume is 50 liters. Your number of moles is 1.9. R is 0.0821. And T is what we're looking for. So to solve this equation, you're going to multiply these two numbers together and divide by those to solve for T. So we're going to do 5 times 50 divided by 1.9 and divided by 0.0821. And you should get T is equal to 1602.67 Kelvin. Okay. Okay, next example problem. It says if I have 2.5 grams of argon gas held at a temperature of 97 degrees Celsius in a container with a volume of 45 liters, what is the pressure of the gas? Okay, so we're in grams. So we have to convert those grams to moles. Now the symbol for argon is Ar, and it has a molecular weight of 40. So if we're looking at our periodic table, argon's right here. It's got a molecular weight of 40. So we can convert that to moles through the molecular weight. So we're going to do 2.5 divided by 40, and you should get 0.0625 moles of Ar. So we're going to go to our ideal gas law. PV is equal to nRT. Your pressure is what we're looking for. Your volume is 45 liters. N is 0.0625. Your R is 0.0821. And your T is your temperature in Kelvin. It's in Celsius, so we're going to go ahead and just add 273 to it right there. So when we put this in our calculator, we are going to multiply these numbers and divide it by the 45. So 0.0625 times 0.0821 times 97 plus 273, and we're going to divide it by 45. So our pressure comes out to be 0.0422 ATMs. Hopefully this was helpful. You'll complete the practice problem homework sets over this, and hopefully you have a good afternoon. Reach out if you have any questions. Thanks. Bye.